This podcast is proudly sponsored by Weather Call Services. Don't be caught off guard by severe weather. Choose Weather Call. Hello, everyone, and welcome to another episode of Across the Sky, our national Lee Enterprises weather podcast. I'm Matt Hollander, based in Chicago, and I'm joined by my fellow meteorologists, Joe Martucci in Atlantic City, New Jersey, Sean Sublett in Richmond, Virginia, and Kirsten Lang in Tulsa, Oklahoma. And guys, this week, I think our topic is very timely. With the parade of winter storms we've had across the country, there have been lots of reports of accidents and stranded vehicles on the roadways. Dr. Scott Mackaro with Vaisala Xweather is our guest, and he's going to talk about the efforts to try and limit weather-related car accidents. But before we get to the interview, guys, do you have any stories about weather and driving? Any close calls on the roads? Any weather-related accidents? Hopefully not.
I remember when I was in high school, this was senior of high school, I had a 1991 Toyota Camry. Now, this was in 2008, by the way. It actually got voted the third worst car in the parking lot at high school. I was actually trying to get a campaign to be first place, but I lost out. Anyway, I was about, I don't know, maybe a mile away from, maybe not even, less than a mile away from school. So I made a left-hand turn. The road was pretty much ice and snow. Left-hand turn. I was going like 15 miles an hour. I pretty much knew as soon as I was making a turn, I'm like, yeah, I'm going to start skidding. And I skidded, and I kind of did like a nice little like swoop around. Thankfully, it was a quiet street. There was no one on it, but there was a parked car not too far away. But I did miss that one, thankfully. And then actually here at the Press of Atlantic City, this was 2021. I was on the Atlantic City Expressway going through like the high-speed toll booth, and actually it was actually pretty scary. You had a tractor trailer coming. I did kind of fishtail. I ended up pulling myself back in, but when you have a tractor trailer not too far behind you, you're kind of wondering what's going to happen. Those are my two experiences. Other than that, thankfully, it has been good, but those are two that I remember.
All of mine are in Colorado. When I spent, some time out there for a couple of years, 2013, 2015, I think. But man, there were just those roadways would get dicey. And it didn't matter if you were in the city, or out of the city going up, passes heading to the mountains. I think the one that sticks in my head the most, and I wasn't even driving. I was a passenger, was headed out to Steamboat Springs, and it was nighttime, and it was like we really probably shouldn't have been driving. I mean, you could not see in front of you, and not even a quarter mile. It was bad, blowing snow, roads completely covered. Thank God I wasn't driving. The driver was a friend of mine, and he was like, just close your eyes. Just, close your eyes and lay your head down. You're gonna be fine. I just gave it to him and did that. But yeah, I mean, we made it, obviously, but that was probably the most nerve-wracking story I have with road conditions.
Late 80s or early 90s. I think I was still in college at the time. I was driving. Joe, you want an ugly car, buddy. Yeah. So this was in the late 80s or early 90s. And I was driving a 1977 Buick Regal.
Yikes. That's like
brown Buick Regal. Basically, I did a 180.
Like a grandpa car.
It was totally my grandfather's car. Not even kidding. Not even kidding. In fact, I went with him to the dealership in 1977 as a lad to go pick it up. But anyway, I did a 180 in the middle of the road and ended up skidding off the road into an embankment. But the car stayed on. I literally just drove it away. I didn't hurt anything.
They don't make them like they used to.
No other cars were on the road when I hit the brakes. The only other thing that was kind of bad, it was a driving snowstorm, and I was driving to work to go on the air, and this was back in Roanoke, Virginia. And I pull into a service station. I wanted to get some snacks. There was already 5 or 6 inches of snow on the ground. We had to go on the air in 2 or 3 hours. So it's like 1:30 a.m., 2 a.m., and there's like one place open. And the snow had piled up so much, I went to turn into the parking lot, and actually I hit a curb because it was so well covered in the snow, and my tire just was done. The whole thing done. So we just moved it on the side of the road. Somebody had to come pick me up. So those are my two horror stories.
The show must go on, and I have
Oh my
one.
gosh.
I have one similar experience about trying to get to work. It's when I was in Richmond, Virginia. Actually, I was trying to get to the TV station, get to the job, and it's happened. If it had been in the middle of the night, it probably wouldn't have been an issue. But because I was going and working a dayside schedule, and so going to work at 9 in the morning, there were other cars around, and so I'm trying to pull out of my apartment complex, and there had been some snow, but the issue was there was refreeze. So there had been some melting of the snow, but overnight it got real cold, and some of that melted snow had created some icy patches. But I would have been a little bit more prepared if I had known there'd been freezing rain all night and that we know for sure they're going to be icy roads. But when you get that refreeze, sometimes it's hard to figure out where it's going to be. Well, I found a nice icy patch in the driveway of my apartment complex. So I'm pulling up to get out on the main road, and there's a car in front of me, and suddenly I have no traction. My vehicle is sliding, and I'm hitting the brakes, and it is just continuing to go forward, and I am bracing at this point. I know I'm going to hit the car in front of me. Like, it is going to happen. I'm going to rear end this car, but at the last second, there was a break in traffic, and the car pulled out on the road, and so I didn't hit it, and then fortunately, I didn't continue to slide into the busy road ahead of me. The ice patch ended, and I was able to stop. But boy, that was a very close call. I was bracing for the impact. I thought for sure I was going to hit the car, but the weather gods, the driving gods were on my side, and there was a break in traffic, and that car pulled out just in time. So, but I think, so for all of us, nobody... Well, I guess, Sean, your car was damaged, but other than that, like nobody was injured or no damages to vehicles because of weather. But Sean, I guess how big was that bill?
Yeah, I tried just to push that out of my head. No.
I don't blame you, but I think a lot of people have similar stories, at least some close calls, or maybe have actually been involved in a weather-related accident. Clearly, extreme weather and cars do not get along, but what's being done to help avoid more scary situations on the roads? We're going to take a deep dive into the world of road weather data right after this break. Stay tuned. And we're back on the Across the Sky podcast. Our guest this week is Dr. Scott Mackaro. Scott is the head of Insights and Innovation for Vaisala Xweather. He's an established leader in the atmospheric science community, specializing in areas of predictive modeling, machine learning, and environmental monitoring. At Xweather, he brings together science, business, and technology to develop innovative solutions to some of humanity's greatest challenges. Scott, thanks for talking with us, and welcome to Across the Sky.
Thanks so much for having me. I appreciate it.
And Scott, to get started with our discussion of vehicles and weather, I just want to establish a baseline. Obviously, there are a lot of older vehicles on the road, but for new cars sitting in dealership lots today, what kind of weather information do those vehicles receive? Is it still just a thermometer that tells you the outside temperature, or has it expanded beyond that now?
Well, there's definitely temperatures in vehicles that give you a sense of what's happening there. But in general, we call this infotainment. So if you think about the information that's in the screen in your dashboard, and of course some vehicles, they're all screens, but at least in my vehicle, I have one little screen. And in that screen, you often get current weather conditions. So you're thinking about things like temperature, maybe an icon telling you about the type of weather that's happening. In other vehicles, you may even see things like wind, rain, and probability. And typically you see some forecast information, whether it's a few hours out or maybe a few days into the future. That information is usually point-based, so it's telling you the conditions where your vehicle is. And in some vehicles, if you have a navigation point set up, it'll give you some indication of what's going to happen at your destination. In maybe some of the more advanced, you'll also see weather maps and sometimes warning information. That's some of the newer information that you're seeing.
All right, I can jump in next on this. My next question is about the data itself. So we think about road data, pavement temperature data. How is that collected? Is it uniform across the country? I mean, obviously, when we think about winter weather, pavement temperature is critical, and probably even more critical than the physical air temperature. So how good, how reliable, how dense are the observations of pavement temperatures? Are they better in some parts of the country versus others, better on interstate highways versus other? I mean, just kind of walk through that a little bit.
Absolutely. I'm glad you brought this up. I mean, I think it's an important distinction because when you talk about data about the roadways itself, your first question was about weather. And these are two very different discussions. The pavement information you're talking about is driven by something called the Road Weather Information System Network, or RWIS as we call it. You find fairly dense distributions of those sensors in what we call winter states, right? So in the states that have entire fleets of snow removal vehicles or road treatment vehicles, you typically find these sensors across highways and in some cases even subsidiary roads. Those networks are fairly robust, more so in some states than other. And actually, these are also global data sets. In fact, the one country you'll find the most sensors per area is actually in the UK. Very, very interesting to see that. But these sensors are measuring not only the temperature and humidity of the atmosphere, but they're doing that at the height of, at a height that's relevant for the road surface. So typically we think about 2 meters for temperature of humans, but we want that a little closer to the roadway to get a sense of what's going on. But we also use optical sensors and sensors with different wavelengths to actually measure what's happening on the road surface itself. In some cases, those sensors are actually embedded in the roadways, measuring things like the temperature, what is the actual content of that water, how much salt, how much chemical. So it's a fairly sophisticated system. And then we also have gap filling technology. So there are gap filling technologies that tend to come in the form of IoT sensors. And those are doing similar things like measuring the temperature remotely of the surface. But again, these tend to happen in the winter states. They are starting to expand more southerly as we're seeing more and more of these sort of impacts happening in places like Texas, in Georgia. These are areas where we are expanding road networks pretty rapidly across the country. Your other question, though, if you could repeat that for me about, was it accuracy or?
Yeah, I mean, how robust is this information? I think about driving down and something triggers on my dash, pavement temperature is down to blank. How are they more in situ? Are they more remote sensing? Is there, is it, wow, it's really good in Pennsylvania because they've spent more money on it versus, Missouri where they don't care. I'm not picking on Missouri. I'm just trying to think, are there locations in the country that this is being done particularly well that you would highlight?
Sure. So what's interesting is the data that we just described, this roadway data, is actually not integrated into vehicles today. Typically, when something shows up on your dash, it's kind of a kludge. It's basically about 37 Fahrenheit or 3 Celsius. It's just a little snowflake turns on, and it's kind of giving you a warning. We've actually done research on that. About 7% of the time is that actually useful and relevant. The rest of the time, it's just telling you it's cold, right? The pavement information today is used in 2 ways. One, in these winter states, these maintenance organizations, the departments of transportations and municipalities, they use this information to make decisions about when to deploy resources, what and how many chemicals to put out, right? You don't want to put out too much chemical. It becomes an ecological problem. You can also save a lot of money by doing that correctly. But most importantly, we want to keep the roads and people safe, right? And so that information is largely used in that use case. Well, you can also use this information in what's called road condition modeling. And this is something we do here at Vaisala, where we're actually modeling the road surface itself, right? And just like any model, you have to have initial conditions to do that, right? You have to have some sense of the road state and how that reacts to even develop a model. So these models take into account, is the road asphalt? Is it concrete? What's it made of? It's essentially it does also incorporate weather, but it's also thinking about things like thermal fluxes with the ground. And that road condition data becomes super important in initializing that and understanding that your model is actually reacting correctly. We call that road conditions. So we want to separate that from what everybody thinks about as road weather. This is actually road condition modeling. That data becomes very important. In terms of robustness, I may be biased as a weather person, but there's never enough data, right? I live out here in Colorado, and as we drive into the mountains, I mean, you could arguably have a sensor every 400 feet, and it would probably look different just because of the elevation changes. So the reality is you have to make your decisions based on topography and different aspects of your road network. So it's really difficult to say that you need to have one every X feet. I would argue there's never enough data, but there's always a cost-benefit ratio for that, right?
Hey, Scott, it's Joe. So, the road conditions, right? I know that some state DOTs have this information available. Is that things you're looking at? I know through my experience, like some states, they have them public. Some states, they have them, but they're not public. And some states just don't have them at all. I believe Connecticut does a really good job with providing public data in that regard, but just want to see what your experience with the states were. And does that even impact what we're talking about here?
My understanding is any of the federal highway data, that's all open. I've never actually found that you couldn't get roadway data unless it was private. There are some cases where there's private data. But for those of us who spend a lot of our time in weather data, it's never easy. This stuff tends to be on different websites and different servers, and it's quite the data engineering challenge to pull together. But when it comes to the ARWIS data itself, I believe that's even part of the METIS data set these days. Many of the states that you just mentioned do even have it on their website, so just anybody can just go and see what the conditions look like. But in terms of the actual systems they use for maintenance, those tend to be separate. So,
got it.
Yep.
And Scott, I want to follow up on that. Now that, again, we do know that this information is publicly available where you can get the latest road conditions on these state websites. And now you're even modeling it, projecting maybe how it's going to change in the future. So what's the biggest hurdle from getting that information into the car, like to appear on your dash or to get an audible alert like ice ahead, and where it's actually a useful alert, again, as you talked about? Because I know those alerts you're talking about, basically it just comes on an ice possible anytime the temperature is 37 degrees, and many times there is no ice. So to get reliable information into the car and into people's hands would be so useful. So what's the biggest challenge preventing that from happening right now?
That's a kind of a multifaceted answer. I'll start with maybe the user experience, right? So it's one thing to have weather information, and many of us are used to pulling our phones out and kind of seeing those apps. And of course, we don't want to pull our phone out in the car, right? But that information is about the weather. So when you think about integrating weather into the vehicle and actually allowing the vehicle to make decisions off of that, right? Or even allowing the user to make decisions. Some of the simple ways to do that is actually integrating it with navigation. We're all used to turn-by-turn directions, right? But how about turn-by-turn weather, right? Especially when it really matters. I think that's the key, is that we want to give drivers information when it matters most. But it's not as simple as just saying, navigation. Now, we work with companies like Here and TomTom to really think about how we're going to integrate that. And that's a whole engineering question, right? Contextualizing that information is also important. There's a lot of weather data out there, but when you think about it, I often say to people that for better or worse, very few people actually care about what the weather's doing. They care about the impact on their decision, right? And how do you make those decisions clearly, and perhaps even more importantly, have confidence that it's the right decision? Where things get a little tricky is that each of these vehicles are different, right? And they have different sensors on these cars. If we think about this from an engineering perspective, the first thing we have to realize is that there are different tiers of autonomous driving in cars, right? When you have like a tier 0, this is no automation at all, right? And then there's a tier 5, which is full automation. And we're not quite there yet when you think about all weather conditions, right? But an engineer isn't just taking into account, okay, they first of all, they may not even be aware that road condition data is available. That's one thing we find often. We spend a lot of our time trying to educate the market that this is even possible. And that's not surprising because I don't think most consumers know that this is possible. They think about weather. They don't even think about the difference that, hey, actually it might be completely clear and now ice is forming, right? These are two completely different phenomena. But the engineers also have to consider what type of sensors are in the vehicle, right? I mean, you have LiDARs and cameras and SODARs and all sorts of information out there. And so each of those sensors have positives and negatives. I mean, it's just very quickly, LiDARs are really good with things like speed and distance. They're also quite expensive, but they are affected by light, but they work in all lighting conditions. But they're affected by weather, I'm sorry, not lighting. Cameras, on the other hand, really, really good at resolution, a little bit cheaper, also affected by weather, and they don't work particularly great at night, right? So you have all of these sensing capabilities out there. And so some of the challenge of integrating this information is also considering everything else that's happening in the car, right? It really is an interesting engineering problem. And then there's a bit of the, well, how would you even use that information, right? So if you have LiDARs telling you one thing, what if the road conditions tell you something else, right? And this is a reality sometimes, right? Because these vehicles are moving sensor platforms, but they can't see what's around the corner, right? That's something I always remind people. It's one thing to say, hey, I'm detecting ice. Well, it's probably too late by the time that you see it, right? And so integrating this information is part understanding what's in the sensors, but it's also part the reality that weather information tends to be just a silo right now in these cars. It's something that they put on the dash, and unless they have to make automated driving decisions, they're not even really considering how weather can play a role in the overall operations of the car quite yet. There are definitely innovative companies out there thinking about this and integrating these things right now. That will probably see the first automated driving cars that are doing adaptive cruise control with weather here in a few years. But that's really just the first stepping stone in all of this.
Yeah, and I think that's what I want to focus on after we take this quick break, is looking into the future and talking about automated vehicles and how is weather making the switch to self-driving cars more difficult. We've got a lot more to discuss, so don't go anywhere. More Across the Sky coming up. This podcast is proudly sponsored by Weather Call Services. Don't be caught off guard by severe weather. Choose Weather Call. Receive precise, location-specific alerts via phone, text, or email. With over a decade of experience, Weather Call delivers pinpoint accuracy for your exact address, ensuring no surprises. Take charge and stay prepared when ominous skies loom. Explore the Weather Call difference today. Visit weathercallservices.com/Lee-Enterprises and safeguard yourself, your business, or any school that matters to you. That's weathercallservices.com/Lee-Enterprises. You can also find the link in our show notes. Welcome back to Across the Sky, everyone. We release new episodes every Monday afternoon on all our leading news websites and apps. But you don't have to listen there. Wherever you get your podcasts, and whenever you like to listen to your podcast, I promise you can find us there. We're continuing our conversation with Dr. Scott Mackaro about cars and weather, and now we want to look ahead to the future and talk about self-driving cars. You know, this has been talked about for years. It's coming. But I still can't take a nap and let my car do all the driving for me. And Scott, I'm wondering if weather is complicating things. Now, there are a few fully automated vehicles out there, but can they handle poor road conditions, or do they only work on dry roads?
That's a great question. Maybe I'll start by saying that, self-driving vehicle OEMs and manufacturers, all weather condition is taken very, very seriously. This is imperative for them, right? Understanding what conditions a system can be available in and be 100% safe, it's just a mandatory part of any development program. But it is really quite challenging. You'll notice that a lot of vehicle companies, or not even just vehicle companies, I guess they're vehicle companies, but people movers and taxis and automated trucks, they tend to begin operations in places where weather isn't much of an issue. San Francisco is a great example. Okay, you do get some rain in San Francisco, and you do get some fog and visibility problems. But in general, people in San Francisco wouldn't consider themselves particularly weather impacted, right? It's a great place to get started. Phoenix is another place, parts of Texas. In the summertime, you do have some problems, but you're largely void of some of the icy conditions that you may experience in other parts of the country. As these companies get more and more mature, all of a sudden weather does become a big pain point for them. Car makers are genuinely interested in having the best possible situational awareness. But again, what's around that corner is often what's causing that problem. Today, these automated systems basically just will let you know that, hey, we're going to have to shut down here soon if the conditions are too poor. There's a company called Zoox that has got a great little people mover They currently only operate in light conditions with some puddles. It's a very specific definition in which they can operate. They too will soon operate in other conditions, and this information becomes more and more important. And that's why when you think about these road weather information systems, I mean, these are part of the backbone of the global weather infrastructure, very important data sets to help people understand and calibrate their data, right?
So what would you say is, what weather condition would you say is maybe the greatest challenge right now for self-driving vehicles?
You know, I think the answer is going to be very similar to any other industry, right? Rapidly changing conditions that weren't really anticipated, right? Specifically to cars, anything that leads to a sudden loss of traction. That's the key thing, right? Your tires are connected to the road, and just like when we're driving, you know, we don't want to all of a sudden not feel control. So that's one big piece. So we think about things like aquaplaning in heavy rains, ice, right? Or even sudden high wind gusts. If you're expecting, you know, to be driving along and all of a sudden your car gets moved, that becomes a problem and you have to recover. Even more of a problem for trucks. In addition, there's also questions about how different weather hinders the performance of different type of vehicle sensors, right? We talked earlier, you may be relying on LiDARs and all of a sudden precipitation causes a problem and now you can't see as well as you could before. So your whole car may be calibrated under clear weather conditions, and now you're in conditions that your car hasn't really had a lot of data to train on yet. So these are the type of challenges that we see coming.
Scott, where does the law stand on autonomous driving in poor weather and if you got into an accident?
You know, I've only seen what I think a lot of us have seen on the news. I'm not actually sure about the law, but what I could tell you is that insurance companies are really quite keen on this. They are paying a lot of attention in terms of what they will and will not cover at this point. Some of these companies will take their own risk, and other companies will abide by exactly what they're insured to. You know, again, I'm not really sure I can speak to the law, but I think to date, as I understand it, some human is still responsible or a company is still responsible along the way, right? I don't see that changing anytime soon. I don't think you can hold a machine accountable in our society today. Yeah.
Okay. Yeah, it's just something I think about, you know, often. My dad also worked in car insurance, so I guess he always has that kind of angle when we're talking about these kind of things.
It's a great question, though. I'd actually like to know the answer where the law stands on it. So maybe a future episode I'll be able to listen to.
Yeah, stay tuned, everybody. We'll come back and chat about it.
Well, yeah, because I think it is interesting, you know, the liability that we're talking about, because are we going to be at a point where we can avoid these fully automated cars driving into a severe thunderstorm or a tornado? Because now a driver can see a tornado ahead of them and stop. But does the car know to stop if there's a tornado ahead of it? Or let's say there's just a lot of hail and the driver can see the hail and see other cars stopping, but are these automated vehicles going to be able to adapt to like a severe thunderstorm crossing a highway, and all the fully automated vehicles stop and wait for the storm to pass? Or do they just slow down and proceed slowly? So has there been any work on how to handle these severe weather situations and tornadoes? Is that in development? Has that problem already been figured out, or is that still a work in progress? Because that's going to be important moving forward.
You know, you're talking about some of the most difficult challenges in predictive modeling, period, let alone with autonomous driving, right? Hail prediction, tornado prediction, these are huge challenges in general. You know, I think we would hope that even non-autonomous drivers would pull over and not be near such things when that happens. So I think if we have the data that lets, you know, an autonomous car know that that's coming, I think it's a very easy pull over and don't move. I think right now they're more concerned with precipitation and ice and snow and slush and really the loss of traction. I think that's where the focus is going to be. And if you think about it, it's as simple as wanting to operate in more places and do it safer. I mean, I think right now the goal, as I understand it, is that these companies want to expand how long you can rely on the automated driving, right? Right now it's clear conditions, certain speed limits, right? Certain cities. They would like to expand that availability to their users. So they're going to step into it on the next level, which would be heavier precipitation. I don't know if they can if they're even thinking about ice yet, right? And so how do they give that confidence? So, you know, I was asking my colleague the other day, you know, how long before we think this is going to be? You know, usually famous last words of anybody in technology, but, you know, we're thinking 2030, 2035 before all weather conditions are really handled. You know, sometimes we're right when we say that, sometimes we're off by an entire order of magnitude because of technology. But if you think about the fact that even the meteorology community can't accurately predict hail and tornadoes quite yet, right? I don't know how a vehicle is going to use uncertainty information that way to make decisions other than I'm pulling over or you're responsible, right?
Yeah, I guess the first step would be to somehow give the vehicle the radar data, like have a version of radar scope in the car, but somehow the car knows that what parameters to stop before proceeding. But obviously it gets complicated. So I'm curious about what your work at Xweather, like how are y'all working to solve this problem? Clearly we've pointed out all how complicated it is. So how are you, what are y'all doing at Xweather to get more road condition data into cars and maybe helping with this transition to fully automated vehicles?
Sure. You know, we've been at this for more than 2 decades. And so it's a fairly multifaceted approach. I'll just kind of bin it into 4 subsections. The first one is filling in gaps in road conditions. Traditionally, we rely on Department of Transportations and municipalities to buy these sensors. And so you're on budget cycles and they do the best they can to meet the needs of something like winter maintenance. We do have a lot of other gaps. So we have these IoT sensors and we actually deploy these as a service and we try to target them on road segments that are particularly problematic. So today we actually model every road segment across the globe. And so how do we make sure that our models are producing something that we can be confident in? Sometimes you need to add more data. And that's not surprising for a company like Vaisala, who's been doing weather sensors since 1936, right? So we are the backbone of the global weather infrastructure. We feel that responsibility to kind of expand that and continue there. The second, probably the most important thing that we're doing, right, is working with our partners really to understand what are their needs, what are their challenges. They also have a lot of data coming from their cars. Can we use these vast, I mean, there's hundreds of millions of vehicles out there, right? They don't all have data today, but as they're producing data, can we help calibrate that? You know, we were speaking earlier about your windshield wipers are on. Well, that might be because of rain, but you might just be cleaning your windshield, or maybe you just hit it. So how do we calibrate that data to be able to trust that information and then even use that to incorporate into our models? On the model side, that's maybe the third thing. We've been fine-tuning this for more than 20 years. Some of it is calibrating with connected car data. Some of it is working with partners like Bosch. You can find some of our work out there where they're listening to the sound of the actual tire on the road and paying attention to what conditions they were experiencing. And we use that data to calibrate our models also. Because what's interesting is if I were to show you a picture of a road and ask you if it was wet, it's a really interesting discussion because the answer sometimes is, yeah, maybe, right? I'm not really sure. The other thing is tire tracks and the snow. So it's really complex when you start thinking about safety. And then maybe the final thing that we're working on, which I get very excited about, is really that contextual piece. And so with the rise of generative AI, we talked earlier about how people are really interested in the decision. So generative AI is turning out to be a really powerful technology for us to take all of this expertise and start to train models to look at all of this data and simply help the user understand what decision they should make. And again, the name of the game there is safety. So those are 4 big areas that we're working in. We're currently integrated into something upwards of 65% of the vehicles, the modern vehicles in the world. So it's quite the operation. It's exciting and it's important.
Yeah, it sounds like a big undertaking. So how many people are on the automotive team at Vaisala?
Gosh, that's a great question. You know, Vaisala is 2,200 people worldwide. The Xweather team is about 10% of that. You know, I'd actually have to check, but you know, I would argue it's a few dozen people paying attention to this, with a few dozen partners out there. And so outside of Vaisala, you know, you've got hundreds to thousands of people thinking about these problems. And some of these people are the smartest people I've ever faced in my life. So we're in good hands, but it's just a matter of patience and time, right?
Well, and it's important work, so I'm glad that y'all are working on it. I think we're going to wrap up for now, but Scott, but right before we wrap up here, if people want to learn more about your work and what's going on at Xweather, where's the best place for them to go?
Sure. Xweather is Vaisala's digital arm of the company. You can just go to xweather.com. You can even click on road information. I forgot exactly the link, but it's all very easy to find. But xweather.com is where you learn about our road conditions API. There's even some really great demos where you can see it integrated with generative AI and fly-throughs and 3D. So it's all available at your fingertips there.
Awesome. Well, Scott, once again, thank you for joining us. Another great discussion about a fascinating topic, and we couldn't have done it without you. So we're going to take one more quick break, but we'll be back with some closing thoughts in just a second on the Across the Sky podcast. And we're back on Across the Sky, guys. Very interesting conversation, but also a lot to unpack. So was there any one thing that stood out to y'all the most?
You know, for me, it's just that we still have a long way to go to pull this, automated driving thing going on. And it was kind of good to hear him speak to that point. There's all kinds of different sensors. They all do well on some things, not so well on others. There is varying amounts of data coming into a car, going out of a car from the environment. This, as they say, is a tough nut to crack. So I don't think it's happening anytime in the near future.
Yeah, I mean, it'll come, but like most things in life, it takes a while for it to get going. I even think about like my own car. I have a new car now, 2022. I don't have that Toyota Camry anymore, but even things like just like lane adjust and like if you try to turn your car a little bit, it'll kind of turn it back for you. Like they're like weird at first. I think part of this equation is just user comfort with this, and are we going to be okay with a fully autonomous car? And I think, and I don't know, maybe I'm just speaking on behalf of myself, but I just feel like if you become fully autonomous, you're eventually going to trust it, and you're going to, really take your eye off the wheel literally your eye off the wheel. And then just in case something happens, then you have an issue. It's like flying like those big jets, right? I mean, a lot of it is autopilot, but you still want two pilots there in case something goes wrong. That's easy in a profession where you're getting paid to do that, but when it's everybody, that might be where the challenge is. But I like where it's going. I mean, what he said was great. I think a lot of it has to come to the human element of this as well.
To Matt's point, I feel like it's something that has been talked about for years, and it hasn't quite gotten there yet. And it kind of makes me, it's not that it's not going to, but it's almost like the Jetsons or something, right? It's like this thing that we see in the future, and it's like, this is how life is going to be. But it's like, what are all of the things that actually need to fall into place for that to happen? And I mean, he's right. There's so many different elements that need to still be hit on and fulfilled before that can actually be something that's safe for everybody.
And we just talked about self-driving cars. We didn't even get into flying cars and the complications that come with that. Can you imagine not only trying to figure out what's happening at the surface, but how high do the cars fly and what's going on 1,000 feet in the atmosphere, 10,000 feet up? And then how do those flying cars interact with the planes that are already in the sky? So I don't even know. I know it, and what was it? Was it Back to the Future that said we were in 2015 we were supposed to have flying cars? Wasn't it like, that movie came out in, I don't know, 87, but wasn't it 2015 that we were supposed to have flying cars? No.
They
A
got,
little off on that one.
You
had to take it to the garage and get the hovercraft conversion in 2015. Sure. Some of us remember seeing the first one in the theaters.
Not me.
I was not born yet.
No. It still feels kind of odd though. Quick side note, like, oh, sorry.
85, I'm pretty sure. The first one, a great movie. All of them are great, but that first one especially. Yeah. But the second one was the flying cars. I remember it was Back to the Future 2.
I haven't seen any of them.
What?
No. Stop it.
No. You haven't seen any of the Back to the Future movies?
Negative.
That's your assignment this weekend. Your assignment this weekend, Martucci, is to go watch the trilogy. And don't come back on this podcast until you're done, young man.
At least the first, just at least start with the first one. I mean,
I'm busy this weekend. I don't know if I'm gonna have time. You know, I'm coaching basketball. I'm going down to Atlantic City for the week. We have cousins weekend coming up. We're all getting together. My cousins, my sister, you know, we're all getting together. I don't know if we're gonna watch it.
Watch it tonight. Just watch it
All
tonight.
right. So if you don't hear, if you don't see me on the next,
know.
if you don't see me on the next podcast, that's why I didn't watch Back to the Future.
We're going to wrap up this episode so you can go watch Back to the Future. That's what we're going to
Good
do
idea.
right now. So that's going to do it for this week's episode of Across the Sky. If you like the show, please give us a rating or post a review on your favorite podcasting platform. And if you have a question on anything weather related, send us an email at podcasts@lee.net or leave us a voicemail at 609-272-7099. We'll be happy to answer that question for you on a future episode. For Lee Enterprises and my fellow meteorologists, Kirsten Lang in Tulsa, Sean Sublett in Richmond, and Joe Martucci, Atlantic City, I'm Matt Hollander in Chicago. Thanks for listening, everyone. Stay safe on the roads, and we'll talk to you again next week.